Hello dear students, I hope you all know me well. Myself, Purushottham K Pabhu, faculty in chemistry. Guys, I have seen from years of my teaching career that majority of the students will struggle a lot while solving problems in organic chemistry related to your NEET exams, JEE mains exams and CET exams. So in order to make the organic chemistry simple, I am here with the most fundamental concepts of organic chemistry, and we will study the most fundamental concepts of organic chemistry under the heading General Organic Chemistry. Okay, so guys, I'll tell you, if you can learn the concepts what I'm going to teach you now in my upcoming videos and all, your organic chemistry will become very easy, and you can solve any higher level problems in your organic chemistry. Trust me. So with this notion, let us start with general organic chemistry. Okay, well, what are the different concepts that we have got to study under general organic chemistry? Here we will learn three concepts. One is called as, I hope you know this very well, electron displacement effects. Electron displacement effects. Yes, can you name the electron displacement effects? Yeah, correct. It is inductive effect, mesomeric or resonance effect, electromeric effect and hyperconjugation. Okay, yes. And then reaction intermediates, very important. Reaction intermediates. Yes, can you name the different reaction intermediates? Yeah, that's correct. Carbocations, carbanion, carbenes, free radical, okay, nitrines and benzene. These are called as reaction intermediates. And finally, we will talk about reaction mechanism. Reaction mechanism. Okay, yes. So please, okay, it's my humble request, come on, learn these three phenomena very well and see that you will solve any higher level problems of organic chemistry. Okay, either it might be your JEE mains, JEE advanced, or else NEET, or else Karnataka CET. Okay, so shall we start with the first phenomena, first concept? What is it? Electron displacement effects. Yeah, before we start with electron displacement effects, let us understand the nature of covalent bond. Nature of covalent bond. I hope you know what is covalent bond, isn't it? By the way, what is covalent bond? Yes, very good. It is nothing but a bond formed by sharing of electrons. Sharing of electrons. Is that correct? Am I correct? Yes, a bond formed by sharing of electrons. If I say how hydrogen molecule is formed, how is hydrogen molecule formed? You will tell me that, okay, hydrogen molecule is formed, okay, by sharing of electrons. Okay, one hydrogen is going to share one electron, and another hydrogen atom is going to share, okay, one more electron. So a bond is formed by mutual sharing of electrons, and we call this bond as a covalent bond. Okay, by the way, how is hydrogen chloride molecule formed? Okay, yes, again through sharing of electrons. Hydrogen atom is going to share one electron, chlorine is going to share one electron. So a bond is formed between hydrogen and chlorine by mutual sharing of electrons, and what is that bond called as? Covalent bond. If you can observe these two molecules, see, if a covalent bond, this is a covalent bond formed between similar atoms, and this is a covalent bond formed between dissimilar atoms. Please note this point. If a covalent bond is formed between two similar atoms, then the electrons of that covalent bond will be exactly at the middle of the two atoms. Okay, that means these two electrons, what are these two electrons? These two electrons are nothing but shared pair of electrons, isn't it? Shared pair of electrons. Okay, so these shared pair of electrons will be exactly at the middle between the two hydrogen atoms. Okay, these two electrons belongs to this hydrogen as well as this hydrogen, and these two electrons will be exactly at the middle of the two hydrogen atoms. But if a covalent bond is formed between two dissimilar atoms, then the shared pair of electrons will not be exactly at the middle. They will be displaced towards a more electronegative atom, isn't it? Okay, yes, we know chlorine is more electronegative than hydrogen. What is electronegativity? It is nothing but the tendency to attract the shared pair of electrons towards itself. Okay, since chlorine is more electronegative than hydrogen, okay, so this will pull the shared pair of electrons towards itself. Okay, as a result, the shared pair of electrons will be more towards chlorine and less towards hydrogen, and hence chlorine is going to develop partial negative charge and hydrogen is going to develop partial positive charge. What is happening here? Okay, due to the electronegativity difference between chlorine and hydrogen, okay, the shared pair of electrons will be more towards the more electronegative atom, and that more electronegative atom will develop partial negative charge, and the less electronegative atom is developing partial positive charge. So that means to say, okay, if a covalent bond is formed between two dissimilar atoms, okay, it leads to the polarity in the molecule. It leads to the polarity in the molecule. Okay, so two poles are formed, a positive pole and a negative pole, due to electronegativity difference. So with this idea, with this basic and most fundamental idea, we will start with electron displacement effects. Shall we? Yes. Electron displacement effects. So what are the different effects? Yes, I told you in the very beginning, yeah, we will come across 4 important electron displacement effects. Which are those? They are, first one, inductive effect. Inductive effect. Okay. Second one, yes, mesomeric or resonance effect. Mesomeric or resonance effect. Third one, hyperconjugation. Hyperconjugation. And last one is electromeric effect. Electromeric effect. So again, note this point, that the first 3 effects, that is inductive effect, mesomeric or resonance effect, and hyperconjugation, these 3 effects are, okay, permanent effects. These 3 are permanent effects, whereas, okay, electromeric effect is a temporary effect. It's a temporary effect. Okay, yes, the first 3 are permanent effects, whereas the last one, electromeric effect, is the temporary effect. So guys, so please make sure you're watching this video, writing each and every concepts, okay, and you're learning simultaneously. Okay, yes, so I'm telling you, inductive effect, mesomeric or resonance effect, hyperconjugation, okay, these 3 are permanent effects, whereas electromeric effect is a temporary effect. Okay, so shall we understand one by one in detail? So the very first electron displacement effect is inductive effect. Yeah. Okay. First one. Okay, inductive effect. Inductive effect. So, what is inductive effect? What are the types of inductive effects? And what are the applications of inductive effect? Okay, so what is inductive effect? For that, let me consider two cases, two general cases. Okay, say for example, I have a molecule of this kind, say CCCCX. I have a molecule of this kind. Please imagine this is case 1. Okay, and in case 2, I have another molecule of this kind, like CCCC. Okay, Y. So wherever I write single bond, okay, you should know that one single bond, one bond represents sigma bond. Okay, if I write a double bond, you should know that, okay, out of double bond, one is going to be sigma bond, the other one is going to be a pi bond. Pi bond. If I write triple bond, okay, you should remember that one will be sigma bond, okay, the other two will be what? Pi bond. Pi bonds, isn't it? Okay, so what bond I am writing here? I am writing single bond. That means I am talking about which bond? Sigma bond. What does that sigma bond consist of? Sigma bond consists of sigma electrons. Sigma electrons. So I have two cases now. One case of this kind, the other case of this kind. Okay, I am going to put certain conditions here. What is that condition? In this case, I will say that, okay, I will say that X is more electronegative than carbon. More electronegative. X is more electronegative than carbon. Okay, so X is attached to carbon through single bond. Okay, this bond is formed by mutual sharing of electrons. Therefore, this bond is nothing but a covalent bond. Okay, so I am here putting a condition. What is that condition? X is more electronegative than carbon. What happens if X is more electronegative than carbon? We discussed a while ago. Okay, if X is more electronegative than carbon, then what happens to this shared pair of electrons? The shared pair of electrons will be displaced towards X. The shared pair of electrons will be displaced towards X, isn't it? They will be displaced towards X. Okay, when the shared pair of electrons are displaced towards X, we know that X is going to develop partial negative charge and carbon is going to develop partial positive charge. Okay, since X is more electronegative than carbon, it pulls the shared pair of electrons towards itself, as a result of which electron density will be more towards X, and hence X is going to develop partial negative charge. Electron density will be less towards carbon. That is why carbon is going to develop partial positive charge. Okay, so what is happening here? Electron is getting displaced towards a more electronegative atom and a polarity is produced in the molecule. This phenomena is called as inductive effect. Very simple. Is that simple? Okay, now I am going to come here. I am going to go with this now case. Okay, here also I am going to put a condition. What is that condition? The condition says, okay, yes, Y is less electronegative. Y is less electronegative than carbon. Okay, yes, here electronegativity difference is with respect to carbon. Okay, X is more electronegative with respect to carbon, Y is less electronegative with respect to carbon. Okay, so now Y is less electronegative than carbon. Conversely, carbon is more electronegative than Y, isn't it? Since carbon is more electronegative than Y, now carbon will start pulling the electrons, shared pair of electrons towards itself. That means the shared pair of electrons will be displaced towards carbon, electron density at carbon is going to increase and electron density at Y will decrease, and hence carbon is going to develop partial negative charge and Y is going to develop partial positive charge. Y is going to develop partial positive charge. What is happening here? The shared pair of electrons, that is nothing but sigma electrons, are being displaced towards a more electronegative atom, and the polarity is produced in the molecule. What is this effect called as? Inductive effect. Simple. Okay. Are we clear? What is inductive effect? Okay. It is nothing but the displacement of sigma electrons towards a more electronegative atom of sigma bond. The displacement of sigma electrons towards more electronegative atom of sigma bond. This phenomena is called as inductive effect. I hope it is clear. Here X, okay, which is more electronegative than carbon, this X, okay, this is called as minus I group, or it is also called as electron withdrawing group. Electron withdrawing group. Understood? Okay, here X, the atom X, which is more electronegative than carbon, it is referred as minus I group or electron withdrawing group. Okay, so what is the charge present on carbon? Partial positive charge. That means electron density on carbon is less. Since electron density on carbon is less, okay, this carbon will start attracting the electrons from the next carbon. Okay, yes, this carbon will start attracting the electrons from the next carbon, and hence the next carbon is going to develop partial positive charge. Again, the electron density on this carbon decreases, due to which this carbon will start pulling the electrons from the next adjacent carbon, and hence, okay, this carbon is going to develop partial positive charge. What is happening here? The inductive effect is traveling along the chain. The inductive effect is traveling along the chain, okay, up to where? Up to the third carbon. But after third carbon, okay, inductive effect is going to become insignificant, or else inductive effect is not valid after third carbon. After third carbon, okay. Here what is happening? Here, okay, we said Y is less electronegative than carbon, isn't it? So this group Y, this Y is called as plus I group, or it is also called as electron donating group, because it is donating the electrons towards carbon. Electron donating group. Understood? Okay, the group Y is called as plus I group or electron donating group. So now, so carbon is more electronegative with respect to Y, hence carbon, okay, is pulling the electrons towards itself. So carbon, okay, there is partial negative charge on carbon. Now this carbon, okay, will have more electron density, and hence it will start drifting its electrons to the next carbon. So that means this carbon, okay, will start getting partial negative charge. The electron density on this carbon has increased. Therefore, this carbon will start drifting its electron towards the next adjacent carbon, and hence this carbon is going to get partial negative charge. Here also, the inductive effect is traveling along the chain. You should note this point. The inductive effect travels along the chain and decreases, okay, after the third carbon. Okay, the inductive effect at first carbon will be more, then second carbon decreases, third carbon decreases. Above third carbon, there will be no more inductive effect. Okay, here also the inductive effect will be more at the first carbon, then decreases at the second carbon, decreases at the third carbon, but after the third carbon, inductive effect will vanish. Inductive effect is gonna vanish. I hope you understood. Okay, so what is group? Why X is called as, X here is negative group, minus I group or electron withdrawing group. I'll denote this as EWG. Wherever I use EWG, you should note that it is electron withdrawing group. Okay, what is Y called as here? Y is plus I group or electron donating group, and I'll denote this as EDG. So wherever I use EWG, electron withdrawing group, wherever I use EDG, electron donating group. Okay, simple. Any doubts? Yes. Well, this inductive effect is called as negative inductive effect. Okay, negative inductive effect, whereas this inductive effect is called as positive inductive effect. Positive inductive effect. Okay, so that means inductive effect is of two types: negative inductive effect and positive inductive effect. What is negative inductive effect? Look here, if the shared pair of electrons is displaced away from carbon, yes or no? Here this shared pair of electrons is getting displaced away from carbon. That means, okay, they are getting displaced towards an electronegative atom, yes or no? Correct? Okay, so if the shared pair of electrons are displaced away from carbon, then it is called as negative inductive effect. But observe here, the shared pair of electrons are getting displaced towards carbon, isn't it? If the shared pair of electrons are displaced towards carbon, then it is called as positive inductive effect. Positive inductive effect. Okay, so, and you should also remember that, okay, in another way you should remember that if a negative minus I group, or else if an electron withdrawing group is attached to carbon, then there will be negative inductive effect. If electron donating group is attached to carbon, then there will be positive inductive effect. Okay, so please note this point. Okay, if electron withdrawing group is attached to carbon, then it is going to show negative inductive effect. If electron donating group is attached to carbon, then it is going to show what type of effect? Positive inductive effect. I hope you now know what exactly is inductive effect. Okay, so shall we list out some of the characteristic features of inductive effect? Yes. Okay. What are the characteristic features of inductive effect? Yes. Look at here. Okay. So first thing, what exactly is inductive effect? Inductive effect is nothing but, okay, what type of displacement? It is partial displacement of sigma electrons, okay, towards okay, more electronegative atom, towards more electronegative atom of sigma bond, electronegative atom of sigma bond. Okay, then yes, we know inductive effect leads to, okay, yes, what? Partial charges are developed. Partial charges are developed. Partial charges are developed. Okay, that is why I said del positive or del negative. Okay, yes, the atom towards which electrons are displaced, it is going to get, okay, partial negative, and the atom, okay, where the electrons are displaced away from it will get partial positive charge. So it leads to the development of partial charges. Yes, and last, very important, okay, very important, yes, what is that? That inductive effect travels, okay, and decreases along the chain, travels and decreases along the chain, decreases along the chain, up to which carbon? Up to third carbon, up to third carbon. Okay, so you are not supposed to forget these three important points. Okay, and I said inductive effect is of two types. What are those two types of inductive effects? Let me write here. Okay, yes, what are the types of inductive effect? We have got two types of inductive effects. One is negative inductive effect, the other one is positive inductive effect. Negative inductive effect is obtained when, okay, an electron withdrawing group is attached to carbon, isn't it? But if electron donating group is attached to carbon, okay, then we observe positive inductive effect. Okay, I hope you don't have any doubts now. Sure? Okay, I'll give you one example for negative inductive effect and positive inductive effect. Okay, yeah. Yes, negative inductive effect and positive inductive effect. Let us give one example. Okay, say that I'm going to consider this. What is it? Okay, I'll take chloromethane. I hope you know the formula. Okay, what is a chloro? What is that? Chloromethane. Okay, CH3Cl, isn't it? This is called as chloromethane. Okay, and then I'm going to consider, okay, what is it? Say for example, tertiary, okay, tertiary butane. Okay, yes, we have chloromethane and tertiary butane. Tertiary butane. Now, what type of inductive effect do you observe in this molecule, and what type of inductive effect do you observe in this molecule? Look at here. We know chlorine is more electronegative than carbon. That means chlorine is more electronegative than carbon. What will happen here? The shared pair of electrons will be displaced towards carbon, and hence chlorine is going to develop partial negative charge and carbon is going to develop partial positive charge. Here the shared pair of electrons are displaced away from carbon. Therefore, what type of effect is it? Negative inductive effect. Negative inductive effect. Okay. And but look here, carbon is attached to 3 methyl groups. 3 methyl groups. We know, okay, these are alkyl groups. Well, we know that alkyl groups are electron donating groups. Okay, alkyl groups are electron donating groups. That means these alkyl groups will pump the electron towards carbon. Okay, alkyl groups are electron donating groups, therefore the alkyl groups will pump the electrons towards carbon. Therefore, carbon is going to develop partial negative charge and these alkyl groups will develop partial positive charge. Okay, what type of effect is it? The electrons are displaced towards carbon, isn't it? Electrons are displaced towards carbon. Since the electrons are displaced towards carbon, what type of effect is it? This is positive inductive effect. This is positive inductive effect. Any doubts? Negative inductive effect and positive inductive effect. Okay. Now, so we are very much clear with negative inductive effect and positive inductive effect. Let us note the order of negative inductive effect and the orders of positive inductive effect. Now, what is it? Order of, okay, minus I effect. This is going to be very important for solving problems. Order of negative inductive effect. See the order. Okay, here it says, it goes like this. Okay, NF3 plus will exhibit highest inductive effect, then NR3 plus, okay, this exhibits more inductive effect than NH3 plus, okay, then NO2, then, okay, cyanide, then, okay, an aldehyde, then a ketone. I'm going to write it here. Okay, then what? Ketone. I hope you know about a ketone. Okay, then carboxylic acids, then fluorine, chlorine, bromine and iodine. Fluorine, chlorine, bromine, iodine. Okay, and then we have alkoxy group. Okay, then hydroxyl group, then, okay, alkenes, and then amino group, okay, which is nearly equal to phenyl group, C6H5. The inductive effect of these two groups are almost same, and then, okay, an alkene, and lastly hydrogen. Please note that the inductive effect of this bond, CH bond, okay, is always taken as 0. Inductive effect of CH bond is always taken as what? 0. Okay, 0. Are we clear? Next, this is the order of negative inductive effect. What about the order of positive inductive effect? Order of plus I effect. Order of plus I effect. Okay, see this order? Yes, CH2 plus will exhibit more inductive effect than NH minus, than O minus, okay, than COO minus, and then, okay, see, come on, what is this? CH3, CH3, CH3 plus. This is nothing but tertiary alkyl group. Tertiary alkyl group, okay, then, okay, CH3, CH3, okay, H. What is this? A secondary alkyl group, okay, which exhibits more inductive effect than, okay, CH3, CH2. That is nothing but a primary alkyl group which exhibits more inductive effect than a methyl group. Methyl group. So please cram or by heart this order, okay. If you can remember this order of inductive effect, negative inductive effect and positive inductive effect, okay, to solve problems it's going to be very easy. Okay, so thank you guys.